Record-smashing heat waves are hitting Antarctica and the Arctic at the exact same time. It's by Dana Bergstrom and colleagues, The Conversation on Science Alert. Record-breaking, we're going to take a look at Null School to see the real-time temperatures there as well. Record-breaking heat waves hit both Antarctica and the Arctic simultaneously this week, with temperatures reaching, this is unbelievable, 47 degrees Celsius and 30 degrees Celsius higher than normal. Heat waves are bizarre at any time in Antarctica, but particularly now at the equinox as Antarctica is about to descend into winter darkness. Likewise, up north, the Arctic is just emerging from winter. There are these two heat waves linked. Are they linked? We don't know yet. It's most likely a coincidence, but we do know weather systems in Antarctica and the Arctic are connected to regions nearest to them, and these connections sometimes reach all the way to the tropics. And is climate change the cause? It might be. While it's too soon to say for sure, we do know climate change is making polar heat waves more common and severe, and the poles are warming faster than the global average. Let's keep in mind that Antarctica has been found to have over 147 volcanoes. Now, some of them are, of course, active. Now, it says here, so let's take a closer look at what's driving the extreme anomalies for each region and the flow-on effects of polar wildlife like penguins and polar bears. What happened in Antarctica? The Antarctica heat wave was driven by slow, intense heat pressure system located southeast of Australia, which carried vast amounts of warm air and moisture deep into the Arctic's interior. It was coupled with very intense low-pressure system over the East Antarctic interior. To make matters worse, cloud cover over the Antarctic ice plateau trapped the heat radiating from the surface. And since it's autumn in Antarctica, temperatures in the continent's interior were high enough to melt glaciers and the ice cap, but that's not to say large swings in temperature did not occur. For example, Vostok in the middle of the ice plateau hit a provisional high of minus 17.7 degrees Celsius, which is 15 Celsius higher than previous record of minus 32.6 degrees Celsius. Concordia, the Italian-French research station, also on the high plateau, experienced its highest ever temperature for any month, which was about 40 degrees Celsius above the March average. The story is very different on the coast as rain fell, which is not really common for the continent to have rain. The rain was driven primarily by the atmospheric river, a narrow band of moisture collected from warm oceans. Atmospheric rivers are found on the edge of low-pressure systems and can move large amounts of water across vast distances at scales greater than continents. Despite their rarity, atmospheric rivers make an important contribution to the continent's ice sheets as they dump relatively large amounts of snow. When surface temperatures rise above freezing, rain rather than snow falls over Antarctica. And last Monday, March 14, air temperatures at the Australian Casey station reached a maximum of minus 1.9 degrees Celsius. 2 days later, they were more like mild summer temperatures, reaching a new March maximum of 5.6 degrees Celsius, which will, of course, melt ice. This is the second heat wave at Casey Station in 2 years. In February 2020, Casey hit 9.2 degrees Celsius, followed by the shocking high of 18.3 degrees Celsius on the Arctic Peninsula. You mean you could go around with a t-shirt like that? So what might this mean for wildlife? Adelie penguins, which live across the entire Antarctic coastline, have recently finished their summer breeding, but thankfully the Adelie penguin chicks had already left for the sea to start hunting for food on their own, so the heat wave did not impact them. The rain may have affected the local plant life, such as the mosses, especially as they were in their annual phase of drying out for the winter, but we won't know if there's any damage to the plants until next summer when we can visit the moss beds again. Now, what about the Antarctic? A similar weather pattern occurred last week in the Arctic. The Arctic, that is, an intense low-pressure system began forming off the northeast coast of the United States. An atmospheric river formed at its junction with an adjacent high-pressure system. This weather pattern funneled warm air into the Arctic Circle. Svalbard in Norway recorded a new maximum temperature of 3.9 degrees Celsius. Of course, that would melt ice, as U.S. researchers called the low-pressure system a bomb cyclone because it formed so rapidly, undergoing the delightfully termed bombogenesis. Now, winter sea ice conditions this year were really very low, and on land there was recent record-breaking rain across Greenland. If the warm conditions caused sea ice to break up earlier than normal, it could have dire impacts for many animals. For example, sea ice is a crucial habitat for polar bears, enabling them to hunt seals and travel long distances. Many people live in the Arctic, including Arctic indigenous people, and we know losing sea ice disrupts subsistence, hunting, and cultural practices. And what's more, the bomb cyclone weather system brought chaotic weather to many populated areas of the Northern Hemisphere. In northern Norway, for instance, flowers began blooming early due to 3 weeks of abnormally warm weather. A harbinger for the future. Modeling suggests large-scale climate patterns are becoming more variable. This means a seemingly one-off heat wave may be a harbinger for the future under climate change. In particular, the Arctic has been warming twice as fast as the rest of the world. This is because the melting sea ice reveals more ocean beneath, and the ocean absorbs more heat as it's darker. In fact, the Intergovernmental Panel on Climate Change, IPCC, projects Arctic sea ice to continue its current retreat with ice-free summers, possibly by the 2050s. Antarctica's future looks similarly concerning. The IPCC finds global warming between 2 and 3 degrees Celsius this century would see the West Antarctic ice sheet almost completely lost. Bringing global emissions down to net zero as fast as possible will help avoid the worst impacts of climate change. This is by Dana Bergstrom, Principal Research Scientist, University of Wollongong, Sharon Robinson, Professor, University of Wollongong, and Simon Alexander, Atmospheric Scientist, University of Tasmania. This is from the conversation Creative Commons on Science Alert. And let's go to the Null School to find out what real-time temperatures are. Here we are at Null School. Let's go to the Arctic first. Here we are. And let's go to the temperatures. Where are we? Where are the temperatures? Air, okay? And temperatures. Temperatures? Whoa, okay. That's around here. This color is around here, as you can see. But you have a lot of warmth here. This is Australia here. Okay, and this is our real-time winds. Let's go to the currents. This is the sea currents, waves. Okay, there you go, and the wind. And let's go to the Arctic now. This is the Arctic. And you can see Greenland. Look at this area here. This is northern Canada, the Northern Territories. This is Siberia. And you can see this area here, the light blue, is around here. Okay, so this is what we're seeing here, the Arctic and the Antarctic. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.